Today I want to explain a little bit how to make debugging using Visual Studio Code. Some other IDEs like idle for Python have different ways to do that, and I'm gonna try and provide a video for that as well. But for the moment, I just want you to show to be aware of how to make the debugging and how to watch variables using this IDE. Usually all IDEs have the same capabilities, so in idle there should be a way to watch variables and to define breakpoints and all that. So since I haven't used that, I'm not gonna make a video about it, but I think I should find one and provide it to you guys as a second choice. All right, so this is a program. This is a program that I made for to solve a quadratic equation. It has two functions and one main program, and obviously the main program is going to call the two functions. Now there's something new here that you haven't seen, which is the try except. This is to handle exceptions, like for example when I want the user to providing the input a floating point number and the user enters a letter, then there's going to be a problem, right? Then you're going to have then runtime error because you're expecting a float and the user enters a string. So when you use this try and except blocks, you can handle those problems where, for example, you have to divide in zero, or you provide a string where you needed a float. You can handle that by just trying to do this code, right? So I'm going to try to get from the user an input, which is a float. But if I can't, if there is a problem or an exception or an error, a runtime error there, then the computer is going to take me to this block of code, which in this case is just to provide a message saying valid input, right? So let's see how it runs. So it's asking me for three numbers. The idea is to solve a quadratic equation of the form of a x squared plus bx plus c equals 0. So I need to provide three numbers, right? So I'm gonna say that I'm going to provide the 1 and minus 6 and then a 9, right? So in this case I have both solutions for the equation, right? Now what happens if I enter, for example, a6, b6 and c6? It's going to tell me that the determinant is negative and the solutions are imaginary, right? So that's one good thing that is this program is catching, right? And it's also catching errors like 6, y, and it's saying, look, this is an invalid input. So that's what the try except is doing here. Now one thing that you need to do when you're checking your code and you're debugging your code is to see well, here there is a way I can start using the debugging console just as you would do in idle, but as I said, I'm gonna do it the way you do it in Visual Studio Code. So in Visual Studio Code, what you do is you create first a profile for this project, and to do that you just need to open the folder where the program is. So I'm just gonna go and open, and here I created a folder which is the workspace where the program is. So if I open the folder, not the file, the folder, then I'm gonna enable this workspace as a working space for this program, right? So right now this is a workspace where I could have this and many other files for Python. So if I want to debug any file here, I'm going to go here to this icon here that says that it's like there's like a little bug there in a play, and what it's going to tell me is that I need to open a file first in order to do that, right? So I'm going to click on the quadratic function file, and then I'm going to click here, and it says that it needs to create a JSON file to do that. This JSON file is going to be like the profile of this project. So it's going to have information about, let me just do that. I'm going to say create a launch JSON file, and I'm going to say that this is for Python, and this is going to create a profile saying that this is I don't know, the name of the project, and the type is Python, and some other configurations that are really kind of advanced for this point, so you don't need to worry about that. You just need to know that we created a profile so we can run the debugging now. Now when I do that, when I created this file, you can see that on the left you have these three sections. One is called variables, one is called watch, and one is called call stack. So we're not going to use the call stack that much, but you're going to see that whenever I call a function, it's going to be loaded here. But this is really useful when you're doing recursion, or when you're doing other types of algorithms where you're calling and calling the same function all over again, where you need to keep track of how many times you have called the function and all that. For the moment, we're going to use just two of these sections, the variables and the watch. So variables, these are, here you're going to see the information of the variables that are currently loaded in memory. And watch, here you can add whatever you want. You can add the same variables or other variables that are not currently loaded here, for example in the function that you're looking at. So let's see what happens when I do the breaking points. Now breakpoints are just points in your code when you want the program to stop to check things. So let's say that in here I want to, whenever someone calls a quadratic function, I want the program to stop there, and here and here, right? Let's call this 4 points. So whenever I enter quadratic function, I'm going to check what's going on in this line of code, this line, and this line. So when I hit the run here on the debugging tool, the program is going to start, and first I'm going to provide the variables that I said, for example 1, -6, and 9, and it's going to start running and it's going to stop right here, as you can see. Now when it stops here, it says, look, right now you have some local variables that are this A, which its value is 1, B, which its value is 6, and C, which its value is 9. So that's very useful when you're trying to debug, because you're checking the values of the variables that you're using in your program, right? So that's something you really want to do when you're trying to figure out what the problem is when you're having some bug in your code. That's why it's called debugging. These problems when you have a logical problem, or maybe a runtime error problem that you're not handling, or something like that, or any error in your code, it's called a bug. So debugging is just finding those problems, those errors, and solving them. So this is very useful for that. Now let's say that, for example, if I keep, okay, that there are usually many ways to go through these steps. As you can see here, I have a function that is called determinant that is also defined right here. So let's say that I don't want to know what's going on inside this function. So if I just want to go from step 3 to 4 to 5 to 6, then I'm going to use this. This is the step over button. So this is going to go over, look, it's going to just jump over that function, right? And as you can see here, now we have D, because D is a variable that we just declare here. So, and you can see that it returned an output of nothing, right? Sorry, the variable output is nothing, and there is this function returned the 0, right? You can also see that I'm right here running the main program, and that I just called the quadratic function, right? And if I had a breakpoint in determinant, then in the call stack I would have here the determinant function. But since I just stepped over it, it's not in the call stack. Now, let's say that, oh, I just forgot something, and I just want to go back and see what's going on inside this determinant, because maybe the value that I got here is not what I want. So what I can do is I go here and I restart the whole thing, and I enter my values, and it's going to go back to this point. So now I want to get inside the next function, the next call. So I'm not going to use the step over, I'm going to use the step into. So I go in the step into, and I go into the next call, and I see that this is a function. If I use the same, I'm going to go into that function, right? Now I can see what's going on inside here, and if I keep hitting this one, I'm going to see what's going on in the local variables. Now I can also add any variable that I want here. Let's say that I all the time want to see what's going on with A or D, for example. So anything that is named E, A, or D, I'm going to be checking those values no matter in what scope I am, or no matter in what part of the program I am. I'm going to be watching these two values. So let's say that I know what the problem is. Now I want to get out of this function and continue with the next step. So what I'm going to do is I'm going to step out, right? So I just stepped out, and then I got my returning value, right? Now as you can see, look, D is not defined here, because right now I just finished the returning value. Now I need to go here, and now D is defined because I got the value out of the function. And I can keep going, and here I'm going to see the variables of any variable that is loaded in memory, and here I'm going to watch whatever I want to watch, even if it's one of these variables or not. And well, I think that's pretty much it. If I just want to keep going, let's say I'm going to just step, and I'm going to keep going. I got the main, and I got my answers, and I see that my program's running, right? So this is one way to do it. This is one way to debug a program. What I want you guys to do is to do the same thing that I just did with this file, okay, in the own IDE that you're using. So if you're using the same Visual Studio, you're going to just repeat what I just did. Okay, so you can see if you understand what running a debug session is, and configuring this file is just making one click in Visual Studio. I don't think that you need to do that in idle. I'm not sure. I'm gonna find out if I provide the video. But for the moment, what I just want you to do is to be able to debug any program that you can get your hands on. So just take this program that I sent and have a happy debugging time. Alright guys, bye bye.